Today I would like to talk about how EMSL is revolutionizing scientific proposal development with LLMs and RAG. So EMSL has a vast amount of data, and it's very challenging when new users want to find relevant information to write a successful proposal development. So some of the challenges are, additional challenges are, EMSL's extensive resources are difficult to navigate, especially for new users. Proposal navigation issues where users often struggle with complex proposal requirements, impacting their success. We have barriers with system complexity. So I did mention that EMSL has a large volume of fragmented data, which creates significant obstacles for new users. We have research proposal difficulties where new users may spend excessive time finding key information necessary to get the information to write their proposals. And then we have impact limitation as a challenge, which resources can restrict its scientific influence and the success of proposal. This means that the time that users are spending looking for relevant information to inform their proposal can be spent focused on the science and writing their proposals. So how do we plan to, or how did we mitigate those challenges? So we leveraged the power of AI, notably large language models and retrieval augmented generation technique to mitigate some of those challenges. What we have done at EMSL, we have built an AI proposal coach chatbot tool that I would have mentioned earlier, where users simply input their scientific question or the abstract, and they get the relevant information that is necessary for them to start writing a successful scientific proposal. Okay, so before I delve into a demo of the AI proposal coach chatbot, I'd just like to touch quickly on what are large language models. And on the right, this is a simplified image that says large stands for AI models that are trained on large data sets. We have language, which says that it works with human languages, and model, it relies on AI models. So we have examples of LLM. As we know, we have GPT, ChatGPT, we have Claude, Llama, we have Gemini, we have DeepSeek, Google Palm, and so on. I also want to just talk a little bit about what is retrieval augmented generation. So our internal data at EMSL was never trained on any of the large language models that we know of today. So to avoid hallucination and guessing, we have to find a way for the LLMs to communicate with our internal data. And this is done via a RAG technique. So that's basically what RAG does. It helps us to communicate with the LLM. So how does RAG work? So a user enters a query via maybe a text. The text is then, it's chunked into pieces and it's converted to vectors via an embedding model. Now, these vectors are then stored in a vector database. And the beautiful thing is that words or phrases or sentences with the same context or similar context can be stored together, sometimes for easier retrieval of information. So once a user asks a query or asks a question, the context is retrieved, it passes into an LLM for further analysis, and then we get the response, the answers to our query. So LangChain, what is LangChain? So LangChain is one of Python's libraries that works well with RAG because it's capable of chaining all the necessary components together. So in this diagram, we have here a document loader. So the person the programmer, whoever's writing the codes for RAG gets an opportunity to upload their document, whether it be a PDF or a tabular data or HTML file or maybe JSON. So it's loaded into RAG. It's then chunked, converted into vectors, stored in a vector database. And also you see we have the LLMs that can be chained. So it depends on the task at hand. You'll select the most appropriate LLM. So you can do that. You see we have the chains there at the bottom. We also have prompts. And prompts are very, very important for RAG because you must instruct RAG as to what it is you want to accomplish. What is the goal? And you do that by simply, writing a prompt. For example, a good prompt would be like, I would like to be able to summarize my documents in a concise maybe, or an intelligent way, or maybe friendly if you want to focus on tone, but you have the option to write your prompts. I'll talk a little bit more about prompts in this presentation, but then we also can chain agents within our RAG infrastructure. So what are agents? In my opinion, from my experience, agents are prompts, but they have several layers, and it seems to be able to do much more powerful tasks, perform much more powerful tasks because of all the additional layers that it has, or components, in comparison to prompts. So why prompts matter? Prompts shape how LLM interprets and respond to tasks. A well-structured prompt can improve clarity, relevance, and accuracy of the output. And here we have, we have different types of prompts. So we have a use system prompt that defines the model's role, as I just kind of used in the example, to summarize documents, tone, and behavior. We also have a use few shot prompting to teach the model through examples. We have chain of thought prompting to encourage step-by-step reasoning. So we have to write all these steps in this example, chain of thought. And there's a use of guardrails, which I've never used, but it's there to enforce safety, boundaries, or policy constraint. It also deals with things like mitigating hallucinations and so on, these guardrails. So this is the fun part. Welcome to the AI Proposal Coach. And this is just HTML. Let me try to get this over here. Hold on. HTML version of the AI Proposal Coach chatbot. So this was, I used a Python library called Streamlit as the UI for this project. So this is what the user sees when they access our app. We have, or the chatbot. The user gets an opportunity to ask their scientific question. They can either ask a scientific question, or they can use their abstract. It is then analyzed, and the next step, it will ask, you need recommendations for EMSL instruments and resources to inform your research plan. Now, these users are competing, so they're writing a proposal because they want to be able to use our internal instrument. EMSL is a user facility. We have all these instruments that are very expensive, so sometimes users want to use them for their own scientific research. For example, they might have soils that they want to be analyzed, so they will need our instruments, right? Access to our instruments in EMSL for the analysis. So here is where, and this is why the first question is, do you want to, access to our instruments? And based on the scientific question or the abstract, the instruments, a list of instruments are returned. See, we have GCMS, LCMS, and this is all based on the scientific question. Some people would say, no, we don't need recommendations for instruments because they probably are an older users that knows exactly the instruments they would want to use. By the way, once the instruments are returned, the next thing that automatically pops up is the IRP and contact person information. Now, the IRPs are our integrated research platforms. We have 8 different IRPs within EMSL. And what it returns is the IRP lead's name, and the person's email address. So this gives the user an opportunity to ask any additional questions that they need, any clarifications. So in essence, it saves them time because under normal circumstances, they have to physically go through our repository or EMSL's website to gather all this information. So immediately they have these contact persons that can give them more information, relevant information to inform their scientific proposal. And also these same persons can refer them to other persons that has helpful information. An additional feature of this is that it also gives the reason why this particular IRP was selected. For example, the biogeochemical transformation IRP is the most relevant integrated research platform for this scientific question because it directly addresses the cycling, transport, and transformation of elements and compounds, including plastic, through microbial processing within various ecosystems. And if you look at the question, it's, the question is talking about recycling and upcycling of plastic waste and how these mechanisms, how can these mechanisms be optimized for industrial application? So it's all based on the scientific question or the information in the abstract. Another aspect of this app, we do have a proposal guidance document. So I've made it where it's easily downloadable. So instead of having to search through the fragmented documents to find it, it's right here at the click of a finger or a click of a button. Another beautiful thing about this app or this chatbot is that once the user has completed their proposal development, they can now upload that proposal into our system. Here I have uploaded past winning proposal, and this would be compared against our proposal guidance template to ensure that they're following all the guidelines. And how it works, our template has several sections. It's broken down into several sections. So for the first one, we have a formatting guidelines, and this focuses on the margin width and the font size and so on. So what it does, it gives a score from 1 to 10 for each of these sections, 10 being that it fully followed our guidelines. So in this section, for this particular proposal, we have a 6 out of 10. So it means that there's work to be done, right? The user can now go back and make the necessary changes. We have an objective section requirement. We have a score 10 out of 10. And we have a little tick here indicating that, okay, it met the requirement, it's specific and measurable, it aligns with EMSL capabilities, it's clearly stated, and overall, section meets all requirements. So it does that, for each section, and then we also have an overall score. So we have a 5.2 out of 10 with a message that reads, your proposal needs several improvements. Please review the feedback carefully. So this gives our users an opportunity to go back and make all the necessary improvements, and maybe they can re-upload and see if if things are better. Additionally, we have a rubric guidance document, so it's downloadable as well. And as a bonus, users can ask any additional questions of our data set and get the answers. Okay, so we wanted to benchmark against a few models to see how well this this chatbot performed, or the models performed, as against the ground truth. So for our ground truth, we had 100 abstracts or scientific questions, along with the instruments and resources and the IRP information. So we're just comparing to see if the AI or the chat bot did better, it performed well enough. And here we have our top performing so far model, which is the O3 Mini. And what it is saying is that for the IRP checks, we have 80% accuracy compared to the ground truth, right? For the resource and instrument, we have a 91% accuracy. For the IRP leads name, we have a 79% accuracy, and the IRP leads email, we have a 79% accuracy. This is another top performing model. It's the Claude 3.7 Sonnet. It's doing well, but not as well as the O3 Mini. So I have a table below that captures the IRP and the two top performing models, the Claude 3.7 and the O3 Mini. And of the 8 IRPs, I did mention that we have 8. It seems as though the rhizosphere function is the one that is not doing so well. It's not predicting well. So of the 100, you remember we started off with 100 observations or scientific questions. And of the 100, we had 34 returned for the Claude 3.7 Sonnet. 34 was returned, rhizosphere function was returned, but 10 out of 34 were incorrectly predicted. For the O3 Mini, of the 100 observations from the ground truth, 41 returned rhizosphere function, and of the 41, 12 was incorrectly predicted. Same with the biochemical transformation IRP. The other 6, they predicted 100% correct. So we have to probably re-examine what's happening with the rhizosphere function IRP and the biogeochemical, or we can start testing other models to see if we get better performance. So the broader benefit with the AI proposal coach, the process has been simplified for the users. All they have to do is to input their scientific question, and they get all the necessary information that is necessary to write their proposal, their scientific proposal, at least to write a winning scientific proposal. It also reduced EMSL staff workload. So now, instead of these users having to ask EMSL staff, every question, they now have the tool that they can use to answer most of the questions. It also supports BR's aligned scientific discovery, and it lays the foundation for future AI tools, including multimodal LLMs, multi-omics integration, AI-driven discovery, and collaboration. Future outlooks. So a next step could be to scale up this approach using the LLM and RAG technique to get insights across other data sets within EMSL or maybe overall PNNL. And we can also integrate an agentic workflow that includes a feedback and learning agent where users get an opportunity to give feedbacks, and so we can improve the tool over time. So I did mention agentic frameworks. I just want to briefly talk about it. These are the components, and of course, these agentic frameworks are there to enable systems to think, learn, and act on their own. So there we have a few components. We have the observation, we have memory, we have tools, goals, agent, actions, and environment. So the memory stores past experiences and context to inform the agent's decision and improve over time. We have the tools. It's an external utility or capabilities the agent can use to interact with data, run simulations, or perform tasks. We have goals, which defines the objectives or outcomes the agent is trying to achieve within its environment. We have the agent, which is the brain, the core decision-making entity that uses the memory that I mentioned, the tool and goals to take action and adapt based on feedback. The actions is a set of operations or decisions the agent executes to influence its environment. The environment is the external system or context in which the agent operates and where it applies its action. We have the observation, feedback, or input the agent gathers from the environment to inform its next step and adjust behavior. So with that said, I want to talk a little bit about Google's AI co-scientists, which has a bunch of agents working to generate research questions, design experiments, and explore novel biological insights, acting as a collaborative partner in scientific discovery. So while I was doing my research on Google AI co-scientists, I ran into a beautiful example, which talks about in the medical field, they tested it by allowing this tool to generate research questions. And they had a turnaround of, very good answers within 48 hours. And under normal circumstances, it would take years for them to generate research questions. So we have 6 different agents having 6 different tasks. We have the generation agent. It generates initial ideas. We have a reflection agent that reviews and critiques those ideas. We have a ranking agent that conducts hypothesis tournaments. We have proximity agents that finds related ideas. We have evolution agents that improve hypothesis. And we have the meta review agent, final checks and summary. So this entire combination of agents created this Google AI co-scientists. Okay, so, as I was researching, I was thinking too about, I could see it like a comparison between the AI proposal coach and the Google system. So we have, or the Google co-scientist system. So their main function is to use multi-agent LLMs to brainstorm, evaluate, and refine. EMSL's AI proposal coach, we analyze research questions, suggest instruments and IRP information, etc. AI approach, we have the Google co-scientist. It's a multi-agent collaboration mimicking scientific dialogue and reasoning. As against us, the proposal coach, we use LLMs and RAG to provide tailored responses and proposal guidance. We have the output, it's exploratory hypothesis for the co-scientists, experimental suggestions, cross-agent debate. And we're more targeted, actionable proposal content, and EMSL resource matching. So I just wanted to see, the comparison. And yes, on a high level, we can say that from the AI co-scientists, we have the ideation, we have the development of research questions. And with the development, our proposal coach, we're actually using those research questions to get additional information for proposal writing. This is another agent-based platform called the Future House platform. And this is designed to answer complex scientific questions in chemistry. And so we have 4 different agents. And this was built by a nonprofit AI for Science Research Lab in San Francisco. So they have these 4 agents, the Crow. And Crow is also known as the Data Scout. It gathers and extracts relevant scientific data from structured and unstructured sources. We have the Falcon, which is a synthesizer. It synthesizes and connects information to form coherent scientific insights. We have the Owl, which is a validator. It validates the accuracy, logic, and scientific rigor of this synthesized knowledge. And we have the Phonics, which is the explainer. It generates clear, reference, and interpretable answers for human understanding. So this is just another example of how agents can work together to do something really big and powerful. For example, answer complex scientific questions in chemistry. So I found this really cool YouTube video.
Natasha, excuse me, sorry to interrupt. Could you just introduce the video? Can you share the link so people can watch it later? Because we have only 1 more minute, so we would like to give some time for a few questions. Okay.
So I did share it with our internal persons for them to share. But yeah, this is the video that delves into Future House platform. It's just 10 minutes. It's very informative, very easy to understand, and enjoyable. And here I want to give my acknowledgements to Dr. Bilbo she's my PI and she's also my mentor. And thank you for this wonderful opportunity. Harsh Botika, he helped a lot with providing the ground truth information. And with that, I want to say thank you so much. And here is my contact information. And, feel free to ask any questions. And I hope that you would have learned something today.
Thank you so much, Natasha. Great presentation.
Thank you.
Do we have any questions here in the room?
Hi, great presentation. Thank you so much. I have a question related with the AI proposal coach. How good is it to let you know what you are proposing is impossible? Because once I heard a PI that she was trying to introduce a gene from a bat to human cells, and when she proposed, the reviewer said like what she was proposing was impossible. So how good is the chat to let you know like what you're saying is impossible? Like,
it's not designed to tell you that. So it's going to give you an answer based on what the information we have, or that it learns from the information that we have in EMSL. So it will return something, right? And at that point, what it returns, it will ask about the instrument. So at that point, the user gets an opportunity to speak with a professional, maybe the IRP lead, to get direction. But it was not designed to say it's it's impossible.
thank you so much.
Yes.
Yeah, thank you. Still on the AI proposal coach, please, is it available for public use or how can we access it?
Not as yet. It's a pilot. But once we've tested it and we're happy with it, of course, probably. Ivette, can you jump in there?
Yeah, so we are working on validating, making sure that the answers are good enough. Working also with the IRP leads and our experts, our scientists. And once we finish this process, the plan is to deploy it part of Science Central, or the current Nexus system that will be Science Central, so the EMSL user will be able to access it through our portal. Thank you. All right. Can we have one more question? We are running a little bit out of time, but yeah, one online question. Let's take. Do we have questions online, right? Let's see. Yeah, let's hear about the link.
Yeah, I probably can share the link also in the chat.
I think this is a little long question. Is there a potential challenge here for reviewers if proposals all begin to be revised and shaped in the same way because of this model? So
So this is why one of the things we probably should do is have those people verify the information with the IRPs, right? Because as it is right now, they only communicate with the IRP. So this is just an additional help. But then they should verify everything or speak with the IRP leads to ensure that, everything is good.
Yeah, so and the goal of this tool is not to write the proposal for you. The goal for the tool is to help you find the right resources to write the proposal. So we all have different kind of questions and research, so it's very, it will be less unlikely unless we are all researching the same topic, then our proposal will be the same, right? So it's tailored to depending on the user question.